We use amylases as one of the enzymes, and amylases typically will break down carbohydrates. So if you have either the cell wall, if it's bacteria, or the membrane, we call it, if it's a mold spore, you have to get through that. That's the first line of defense. And amylases will break down that particular cell wall or membrane. We use lipases. In between the multiple membranes on a mold spore are fatty lipids. So you need to be able to get through that. And you've got to break through several of these. That's why mold spores, they're incredibly difficult to kill. So we use a lipase, and that's going to break down fats. And then the bigger issue is proteins that are in the nucleus and the core of the mold. So we use proteases to break down proteins. That's how the enzymes work. Essentially what happens, the product comes in contact with the mold, and the enzymes will lyse the cell wall. Lysing is just piercing the cell wall. They actually dissolve it. The guts leak out, and essentially at that point, that spore is dead. The problem here becomes that in conventional mold remediation, you're always taught that dead mold is just as bad as live mold. Seems sort of odd, the spore's dead. Well, think of it this way. If you had an allergenic reaction to, let's say, beef protein, that steak is dead cow. So that is dead. Heck, you could cook that thing until it was shoe leather, but it's still protein. If you were allergic to beef protein, you would still be allergic to that dead cow. So what happens is we lyse the cell, we're dissolving the membrane, we're dissolving the fatty lipid layer. We get into the nucleus, which is a protein. When people have an allergenic reaction to mold, and most of these common is this allergenic reaction, it's a reaction to that protein that's in the nucleus of the mold spore. So that's what we need to get at. So we call in the cavalry. The cavalry in our case is that protease. Proteases break down proteins. So the enzymes will continue to work on those proteins. And a protein is merely a strip of amino acids, a string of amino acids held together by a peptide bond. It's sort of a glue that holds them together. The protease will break that bond. So what you end up with is harmless amino acids. They're not allergenic. They don't cause anybody any harm. No one gets sick from them. And there's billions of amino acids in our bodies. So that's how this product is breaking it down. Now when you have no more protein, you don't have that allergenic reaction. So no protein, no allergen. I want to compare how our products work compared to most of the chemicals that are on the market. As I mentioned before, the enzymes are catalytic. We enable a reaction to occur. We're not consumed in the reaction. Your chemicals are stoichiometric. They are completely used up instantaneously. They cannot continue working. You need to have a lot of them. You need to hit every mold spore. The enzymes being recycled and not used up in that reaction are very persistent. They just keep on working. The chemical can't do that. This is what makes our product safer and more effective.